Hi, welcome back. This is Professor Ridge, and today's lesson is on section 8.3, Geometric Sequence and Series. A sequence is geometric if there's a number r called the common ratio such that a sub n plus 1 over a sub n equals r, or a sub n plus 1 equals a sub n times r for any integer n greater than or equal to 1. So again, it's common ratio because we take the ratio of two terms to get r. So for example, and then again, this way is kind of how you build the geometric sequence recursively. So let's say I started with 3, and then to get the next term, so we'll call that my first term, and then let's let r equal 2. So a sub 1 will be 3, and then a sub 2 will be 3 times 2, which is 6, times 2 would be 12, times 2 would be 24, times 2 would be 48, times 2 is 96, times 2 would be 192, so on. Okay, so this would be a geometric sequence. And then note, if you took a sub 3 divided by a sub 2, that's going to be 12 divided by 6 will be 2. Or I could do a sub, let's see, this is 1, 2, 3, 4, 5, 6, 7. If I did a sub 7 divided by a sub 6, that will still get me 2. So that's why it's common ratio, because if you divide any two successive terms, you're going to get 2. And again, it has to be the latter one divided by the one that's right before it. Okay, so let's find the common ratio. So r will be negative 6 divided by 18, because we're going to do a2 divided by a1, which is equal to negative 1/3. And then you can check. 18 divided by, or times negative 1/3 is negative 6. Negative 6 times negative 1/3 is 2. 2 times negative 1/3 is negative 2/3. So it all checks out. Okay, so again, r, just do a2 divided by a1. So 858 divided by 780. And then punch that in your calculator, and you should get 1.1. And again, you can check just to make sure that it's the common ratio. You can just go 780 times 1.1. You should get 858. 858 times 1.1 is 943.80. And then times 1.1 again, and you should get 1038.18. And it checks out. Okay, and so the nth term of a geometric sequence. So the nth term is given by the formula a sub n equals a sub 1 r to the n minus 1. Okay, and we can learn how this formula came about doing a similar argument we did with the arithmetic sequence. You know, the way we built it. So if you think of it as a1 is given as a1, a2 is a1 times r, a3 is a2 times r, but a2 is a1 times r, which is a1 r squared. And then again, so a4 would be a sub 1 r to the 3. And you can see that it's going to be, this pattern emerges where it's going to be a1 times r to the one less power that's one less than the term you're on. Okay, because when we start off the chain, a1 is just a1. It's a1 times r to the 0. And so then you get this a sub n is going to be a sub 1 times r to the n minus 1. Okay, so pretty similar argument that we did with arithmetic, but now we're multiplying instead of repeatedly adding. We're doing repeated multiplying, which is exponents. Okay, so the nth term is going to be a sub n equals a sub 1 times r to the n minus 1. So the only thing we need to figure out is what's a sub 1. Well, that's just the first term. And r is, we're going to do a2 divided by a1, which is 4 divided by negative 2, which is negative 2. So a sub n is a1, which is negative 2. R is negative 2 to the n minus 1. Now, that's the nth term, but since both of these are both negative 2, the bases, we can use exponent rules and combine it. And then, so note, if we're doing exponent rules, x to the m times x to the n, what do you do with the exponents? Hopefully you're saying you're going to add them. So if we have negative 2 to the first power, negative 2 to the first power times negative 2 to the n minus 1, that's going to be negative 2 to the 1 plus n minus 1, which simplifies to just negative 2 to the n. So that would be the nth term. Okay, so this one, let's find the 9th term. And again, we can just figure out what r is. So we're going to do a sub 2 over a sub 1, which is 10 divided by 2, which is 5. So the 9th term, a sub 9, is going to be equal to a sub 1 times r to the n minus 1, which is 2 times 5 to the 9 minus 1, 5 to the 8th. Punch that in our calculator, and you should get 781,250. Alright, so for a series, remember that's the sum of the terms of a sequence. The sum of the first n terms of a geometric sequence is given by s sub n. So there's that notation again for series. And that s sub n is equal to a sub 1, first term, times the quantity 1 minus r to the n, and then all that divided by 1 minus r for any r not equal to 1. Okay, so let's look at an example. Okay, so we're going to find the sum of the first 10 terms of the geometric sequence. We have 16 minus 8 plus 4 minus dot, dot, dot. Now for a geometric sequence, if you notice in the formula, we don't care what the last term is, we just care about the first term and what r is. So a sub 1, so first let's find a sub 1. Well, it's just given to us 16. And r is negative 8 over 16, which is negative 1/2. Remember, a sub 2 divided by a sub 1. So s sub 10, because we're doing the sum of the first 10 terms, is equal to a sub 1, 1 minus r to the 10 over 1 minus r. So let's plug in the a sub 1, which is 16, 1 minus negative 1/2 to the 10. Now notice how I put that in parentheses. Make sure you do that so you don't mess up the sign. And then 1 minus a negative 1/2. So negative 1/2 to the 10th power, we got to do order operations, is positive 1 over 1024. 1 minus a minus 1/2 is positive 3/2. Okay, and then we can do all the scratch work for this. If we want to leave it as a fraction, you're going to get 341 over 32. And you're all done. Okay, so let's find the geometric series, the sum of the geometric series 3 plus 6 plus 12 plus ... plus 3072. Now again, for the formula, for a series, S sub 10, or S sub n, is equal to A sub 1, 1 minus R to the n, over 1 minus R. Now, we know that A sub 1 is 3. We know we can figure out that R is 6 divided by 3, which is 2. So this is that sequence we did earlier. And now I want to do the sum. And then what's n? So we need to figure out n. So find n first. So we're going to put that formula on the side burner here. And we go back to find the nth term. So find n using A sub n is equal to A sub 1 times R to the n minus 1. So we know that the last term we want is 3072. A sub 1 is 3. R is 2 to the n minus 1. Now what we do first is to solve an exponential. We got to think back. We did that a couple chapters ago. So we divide by 3. So that's 1024. 2 to the n minus 1. So two ways we can do exponentials. We can put ln in front of both sides, or we can write both of these as the same base. So if you can think of 1024 as a power of 2, which is 2 to the 10. So if the bases are the same, then the exponents have to be the same. So 10 equals n minus 1. So n must be 11. Okay, so that's kind of side work there. Now we can find the question to the answer, or the answer to the question, which is, what's the sum of the series from 3 plus 6 plus 12 up to 3072? So n is 11. A sub 1 is 3. 1 minus R is 2. N is 11. 1 minus 2. So we're going to get 3 times 1 minus 2 to the 11 equals negative 2047. And then divided by negative 1. So that's 6,141. There we go. Okay, so now let's talk about the limit or the sum of an infinite geometric series. So when the absolute value of R is less than 1, so R has to be a fraction, well, less than 1. So like it could be 0.9 or 3/5 or negative 3/5, because you're going to take the absolute value of it. So it has, the absolute value of it has to be less than 1. And then the limit or sum of the infinite geometric series is given by this formula, S sub infinity. So infinity is at sideways 8. The first term, A sub 1, divided by 1 minus R. So that's the shortcut formula. Now this concept of a limit is a big idea. If you go on to calculus, that's basically what calculus is based on. A couple other things too, but that's one of the big ideas. Let's look at an example. Let's look at this geometric series where A1 is 5 and R is 1/2. So we got 5, 5 halves, 5 fourths, 5 eighths, 5 sixteenths, 5 32nds, and sorry about messing up here, but 5 64ths, 5 over 128, and 5 over 256, so on. And if I wanted to find S sub 1, that's the sum of the first one term, that'd be 5. So I'm going to show you this concept of a limit. S sub 2 would be 5 plus 5 halves, which is equal to 5 plus 5 halves is 7.5. S sub 3 would be, so 7.5 plus 5 fourths, so just 5 divided by 4, so that would be 8.75. S4 would be S3 plus 5 eighths, so 8.75 plus 5 eighths, so 5 divided by 8, it's 9.375, and S5 would be 9.375 plus the next term, which is 5 sixteenths, so that's going to be 5 divided by 16, so we get 9.6875. And the reason I wrote it this way is just because, now look, you're adding 5 16ths. The next one I'm going to add 5 32nds, which is 5 32nds. 5 divided by 32 is 0.156. So it's getting, we're just adding a smaller number. So S6, I'll write it over here, S sub 6 is 9.84375. Okay, S sub 7, so now we're going to add 5 64ths to that. 5 divided by 64, so again, it's growing, but the amount that it's growing gets smaller and smaller. And you can see 9.92 S sub 8. So S sub 8, we're going to add 5 over 128. So that's 9.9609375. So this concept of the limit is there, you know, every time I add the next term, the next term gets smaller. So is there a limit to how big this can get? You know, what's S sub 100? What's S sub 1000? And, you know, does this just keep growing forever? And the answer is yes, but does it go to infinity? And the answer is no. It actually limits out, and it turns, if you look at this progression, this one actually ends at a nice whole number, and, you know, if your guess is it's around 10, that's a good guess. It's actually going to be exactly 10. So let's look at that formula that we just found up here. So S sub infinity is going to be A sub 1 over 1 minus R, which is 5 over 1 minus 1/2, which is 1/2. 5 divided by 1/2 is the same thing as 5 times 2, which is 10. Okay, so the limit is 10. And the idea is you can't actually add an infinite number of items, but if you could, it would be equal to 10. All right, so that's, you know, the concept there. So that's why they say the limit. The limit of the sum is going to be 10. You can't get more than 10. You can get as close as 10 you want just by adding a whole bunch of terms. If you could add an infinite number of terms, then it would be equal to 10. All right, so let's find the sum if it exists. So we got the summation of 1,000 times 1.06 to the negative k, where k goes from 1 to infinity. So this is an infinite sum. So we got 1,000 times 1.06 to the 1. oh, that's negative 1, because it's negative k, plus 1,000 times 1.06 to the negative 2, plus dot, 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 forever. And so before we can use the shortcut formula, we got to note that r is equal to 1,000 times 1.06 to the negative 2 over 1,000 1.06 to the negative 1. So the thousands cancel. We get negative 2 minus a negative 1. So it's 1.06 to the negative 1, which equals 0.94333, which is definitely, the absolute value of that is less than 1. Okay, we have to check that first, that it's less than 1. Alright, now we're ready to use the formula. So S sub infinity is A sub 1 over 1 minus R, which is A sub 1. So we got to figure out A sub 1. Well, it's just 1,000, 1.06 to the negative 1. 1 minus 1.06 to the negative 1. So 1 minus 1.06 to the negative 1 is okay, so this equals 16,666.66 forever. Okay, so just punch all that in your calculator. Make sure you put parentheses here when you punch it in your calculator. Alright, let's try one more. So what is the summation of 12.5 to the k? So that's 12.5 to the first plus 12.5 squared plus 12.53 plus dot dot dot. So S sub infinity is A sub 1 over 1 minus R, which is 12.5 over, now note R is 12.5 squared divided by 12.5 to the first, which is 12.5. So 1 minus 12.5. And you punch it into your calculator. And again, you better use parentheses here. 12.5 divided by parenthesis 1 minus 12.5, close parenthesis, so negative 11.5. So you get negative 1.0869 and some change, right? So now, if this was a multiple choice test, obviously that answer would probably be there, and then you get it marked wrong and you wonder why. And so the answer is, well, you can't do this because absolute value of R is not less than 1, right? It's not less than 1, so you can't do it. It doesn't exist. So it does not exist. Or you can say it's infinite. Okay? And obviously the negative 1 point whatever wouldn't make sense because 12.5 is a positive number and the whole series is positive. 12.5 squared is 156, so right away you got 12.5 plus 156.25 is 168.75, and he's just getting bigger and bigger and bigger, so there's no way it would be negative. So again, the formula can only work if R is, the absolute value of R is less than 1. So be careful about just plugging it into that formula. Now we can do partial sums for anything, provided R is not 1, and you use the other formula. So this formula only works if R is less than 1. Okay, can't say that enough. Okay, so that concludes the lesson for 8.3. Go to my math lab and complete the exercises there.